Well, thanks for joining us today, and we'll be focusing a little bit more on connectivity issues in Kubernetes and how we can actually troubleshoot microservices. So we can actually use this ideas, these tips and tricks to actually troubleshoot what we've discussed in the previous sessions 2 weeks ago and 2 weeks before that. So I'm Philip, I'm a solution architect at Gira in Calico. I'm here today with Jane. She's my colleague, she's based in the UK.
Hello.
And she handles the sales operations. If you want to check us out, go to LinkedIn. You can find our entire background, but we both have a long time experience in everything which is related to networking and security and containers and Kubernetes. So speaking for myself, we're getting old. So the agenda for today is a small overview, as usual, and discuss a little bit of the ideas on how Calico works and how we can actually troubleshoot the connectivity, how to do it in the open source way. And we'll focus a little bit on how we can do it in the enterprise version of Calico. So I guess you all know by now what Calico or Project Calico is, but at the end, it's an open source solution, which is actually making sure we have networking inside of Kubernetes and honestly also outside of Kubernetes, and also an implementation of network security policies, an extended version of network security policies, as you might know them in Kubernetes, which is used across a whole broad range of platforms. So you can actually use Calico network policies in most public cloud environments, as well as on-premise solutions. So check it out. This is mainly true also for the open source as well as the enterprise version. The enterprise version, of course, adds enterprise functionality, which, for example, is more advanced security policies, but also multi-cluster management and even federated security across your hybrid cloud. So if you want to know more about Calico Enterprise, go to tagira.io or just reach out, of course. Here is a small new way of presenting what Calico Enterprise is actually doing. So there's quite a lot of that we can actually enhance Calico with. Most importantly, north-south controls like firewall integration, SIEM integration. A very popular topic is also DNS policies, which allows us to basically create access lists or network policies based on DNS names, and so on and so forth. Another one which we'll cover in 2 weeks from now is the IDS part and the compliance and security part of it, and the hotspot. The honeypot feature. So last time we did this workshop, the honeypot feature was not available yet. Today it is. So in 2 weeks, we'll try to demo live the honeypot feature in Calico Enterprise and how we can do similar stuff in open source and why we need, of course, the enterprise version. Okay. In a few days, we'll have updated versions of ePPF data plane and Windows in the new release of Calico Enterprise 3.5 should be available today or in the coming days. So keep an eye open for that. So once we try to troubleshoot, we have pods, we have our Kubernetes clusters up and running, and something is not working out. We have communication issues among one of the possibilities, of course. How would we basically go on and go forward in trying to figure out where we have to look on solving these issues? So first of all, I think it's very important if you're using a CNI plugin like Calico to basically, how should I say, get familiar with a cluster so that you can actually know what options are used and what options are not used. Because as you know, in Calico, there are quite a few different options to set up your CNI. But one thing to keep in mind, and I have to repeat, or I repeat it almost every webinar, is that never lose track of how the Kubernetes network model is actually working. And the fundamentals are that every pod that are actually, every pod that is spinned up inside of a Kubernetes cluster gets its own IP address. Yeah. So it has to get it from somewhere, and there are quite a lot of different options for that. So keep that in mind. Every container that is sitting in a pod, so a pod can have multiple containers in it, shares the same IP address. We typically take that for granted, but as you will see in one of the examples, we will adding a container to a pod, and this is exactly what is happening. Pods can communicate freely with all other pods in the cluster without the need for address translation. That means that if a pod reaches out to another pod, you will see the real IP address of the pod, which is not the case when you have accessibility from outside, where you typically see the node IP address. For the remark, I learned yesterday that when you're using eBPF, you can actually make sure this is not happening. Of course, when we are using CNI where everybody can communicate freely, there is a big need for security. So there will be network policies in place, or there should be network policies in place. So that means that we have two angles in which we might have connectivity issues. One is the CNI working properly or not? Or two, might there be a network policy in place that is actually blocking traffic as it should or should not? So one big problem to solve is quite often troubleshooting network policies to make sure that they are actually doing whatever they have to do, which is not as easy as it might seem on a slide. So when we talk about Calico networking options, there are a few things to keep in mind. First of all, Calico has a standard way of using encapsulation. That means that if you set up your Kubernetes cluster, when you install the CNI, you have a few options. Quite often, we use an encapsulation technique like IP and IP or VXLAN. The default one is IP and IP. So that means that traffic in between nodes are actually, the packets are actually encapsulated inside of IP tunnels. One of the particularities of Calico is that we also support a non-overlay based solution, meaning that pod-to-pod traffic across nodes is not encapsulated, as the name suggests, so that you can actually, on the underlay network, actually see the original packets. When we're using the non-overlay or the IP and IP way of connecting nodes, we are using BGP. So that means that Calico nodes are exchanging IP routes, BGP routes, to make sure that, in the case of Calico, every node knows about which block of IP addresses is sitting on which node. Okay, so keep that in mind. If you're using Calico and non-overlay or IP and IP, there is also the angle of BGP peering, which is typically solved by node-to-node mesh, so you don't have to care about it initially, but just know that it might be a problem when you're troubleshooting connectivity. If you opted for VXLAN, there is no use in BGP, just be aware of it, but it also changes the way packets are encapsulated. In Calico, you also have the possibility to control how traffic is handled when it actually leaves the cluster. We call it not outgoing. That means that typically when traffic is originating from a pod and going to the internet or to a database somewhere else in the cloud, by default, it is address translated. So meaning hidden behind the IP address of a node. Although Calico Enterprise can use something which is called egress gateways, so that you can actually not everything behind a specific IP or range of IP addresses to identify the application. By default, we typically do address translation when we leave the node. You can turn off that behavior in Calico. So it's not always the case that everything is knotted when you leave the cluster. So check it out if you're actually experiencing connectivity issues with typically external services. Now, another topic that is important to try to understand is when pods are actually spinned up, they need to get an IP address. In the normal networking world, we typically do this through DHCP, which I thought for a long time was the case in Calico, in Kubernetes, but it's not true. So the IP address management is typically implemented in one or the other way. If you're using a full-fledged install of Calico, Calico has a very flexible, very performant IPAM system, meaning that Calico is smart in the way it actually assigns IP addresses to nodes to optimize the routing and so on and so forth. That's the reason why Calico is such a scalable product, because the way you assign IP addresses basically also simplifies routing, BGP updates, and that kind of stuff. So if you can use Calico IPAM, I would sure opt for that idea. If you can't, you typically need to use what is called host local, which is actually nothing more than a text file somewhere that has a list of used IP addresses. As that suggests, you typically, or you easily can understand that it's way less flexible. But quite a lot of CNIs do it that way. In some cases, Calico network policies are used with host local, so keep that in mind. And then last but not least, IPAM, typically when you go to cloud environments like AWS or Azure AKS, they will have their own way of assigning IP addresses, for example, directly from a virtual network or subnet. So always keep that in mind. If you see a pod, if you look at the IP address, make sure that you understand where it comes from, and it will also typically explain if it is address translated or not. Just a few tips and tricks to make sure that you understand how the traffic is behaving when it leaves the cluster and how it behaves actually inside of the cluster. Okay. So to get all that information, I wrote down a few examples here. I will show them in the demo later on. But for example, like Calicoctl node status, if you type that command, always think about when you type this command that it is actually on a specific node. So it will show you whether the BGP neighboring and BGP peering is okay. Always a good thing to do upfront, so that you know already upfront that your nodes can talk to each other in BGP, and that part of the setup is okay. For those that know Calico, you also know that I already explained it, that we are using a way more advanced way of managing IP addresses. And IP addresses are managed in a concept like IP pools. An IP pool, by default, it's called default IP pool, is actually a range of IP addresses that Calico uses to assign IP addresses in the first place to nodes. So I often get that question, where is that IP pool coming from? If you do not do anything and you just simply copy paste the link to install the Calico CNI, the IP pool is exactly the same as the pod CIDR. And the pod CIDR is something you define when you actually install Kubernetes. Yeah. So typically it's 192.168/16, depending on which cloud, but quite often that's the subnet. If you install Calico, you can actually opt to make the IP pool smaller than the original pod CIDR, which will allow you to create multiple IP pools. So it's perfectly possible that in a Calico implementation, you have multiple IP pools. What's the great advantage of having multiple IP pools is that you can actually select from which pool pods actually get their IP addresses. And if you remember what I said a few minutes ago, some might be using IP in IP, some might be using VXLAN, some might be using non-encapsulation. Well, the way you encapsulate or do not encapsulate is based on the IP pool. So in more complex environments, getting multiple IP pools might also indicate that you're using different encapsulation techniques. So if you do get IP pools, -o-YAML, you'll see all the information, whether they're using actually address translation or not, whether we're using encapsulation or not. So keep these commands in mind to actually get a good understanding of how the networking is implemented. The next command, like Calico CTL IPAM show blocks, will tell you how much of the IP addresses are used inside of Kubernetes, are used on a specific node, and will also tell you which block of IP addresses is automatically assigned to which node. So looking at that output of that command will immediately tell you whether you still have free IP ranges available on specific nodes. We might say in a small example, this is not important, but if you have a lot of pods, it might be a showstopper that you're actually running out of IP addresses. Calico can solve that by adding multiple blocks to a specific node, but in some other cloud environments, for example, you're limited to 100 or 110 pods per node. So keep that in mind. It's also something important when you size your network / your nodes to know upfront how many pods you will be running more or less on a node so that you have enough IP address space. We'll see this command. I wrote them down somewhere in GitHub so that you can actually take a look at them and copy paste them. Now, in contrast to most other CNIs, Calico uses Linux interfaces in quite a different way. This is a more advanced example, but as I said, Calico can use IP and IP or non-encapsulated and VXLAN. If you're using VXLAN and you do ifconfig on the node, you can actually only see the VXLAN Calico interface, typically represented as one interface. VXLAN uses a concept of bridges and tunnels and so on and so forth. So it might look very simple, but you have to dig deeper into other areas of the switch or the virtual switch. If you're using Calico IP and IP or you're using non-encapsulated mode, every pod actually gets a network interface on the node. That means that if you do if config, you can see interfaces like Kali something. These are actually network interfaces that are actually mounted into the pods. That means for every pod, you will have a Kali interface, which is good news if you want to troubleshoot it, because you can actually see it over there. In the next trick, it's also very useful to know that. But these interfaces, in contrast to VXLAN, these interfaces are actually connected to actually the routing or the virtual router that is actually on the Linux node. So that's a subtle difference, but it's a difference. Okay. So if config, although it sounds very old school, can still give you quite some good information about what interfaces, how many pods, and so on and so forth are running actually on your node from a Linux point of view. Of course, it all depends on the routing. So typing commands like netstat -r or IP route will also show you how everything is routed inside of your Kubernetes cluster. If you have the time, if you have a Kubernetes cluster available, do it, because it will learn you quite a lot about what block is sent to where. For example, in this case, the /26 routes that you see, like for example, 168.13 and 64.128 are actually blocks. As you can see, to reach these blocks from a specific node, we are actually sending it to another node IP address. I know this because this was my cluster. So every node should have basically routes for these blocks to know how to reach the other nodes. This is actually learned by BGP, and this is also updated by BGP. So that's why it's all so dynamic and scalable inside of Calico. Now, one of my favorite things to do in Linux and containers and pods is why is something not working? Yeah. Of course, there can be an application issue, so you can check the application logs and so on and so forth. But imagine that we're convinced that our application is working and that we have some idea that the network is not doing. How can you actually TCP dump or use Wireshark if you want on Kubernetes? There are a few ways to do that. There are some tools which require you to install quite a lot of stuff on Kubernetes and to extend Kubernetes. Of course, you can use Calico Enterprise, as we will see later on. But if you want to do it, let's say, on the open source version on Linux, there are a few options that will actually work or show you some information, but not all. So the first way to actually go and analyze the traffic is to try to TCP dump on the Linux host itself. Now, although this can be challenging because it actually knows that you need access to the Linux nodes, first of all, but quite often if you just TCP dump on a host, it will not show you quite a lot because of the way that everything is routed, or in the case of VXLAN, everything is hidden behind a switch. And these switches, as far as I know, cannot be put in monitoring mode. So really doing some TCP dump straight on the Linux host, unless you're very experienced with namespaces and so on and so forth, might be quite challenging, although not impossible. In Calico, as I mentioned, you might have Calico interface or Kali interfaces. In that case, it becomes easier because you could actually do a TCP dump on that Kali interface. And so you could actually intercept the traffic of that pod. But this only works when you have Kali interfaces. So I tried to figure out a more general way that also works in cloud environments and so on and so forth. So one of these solutions is by using a sidecar container. So there are some tricks, and I will show it in the demo, to actually inject the TCPdump container straight into a pod and capture the traffic from inside of the pod, which I find is a pretty cool way of doing it. The downside is that the pod needs to be restarted. But if you are in a test or dev environment, you can get away with it. Another nasty trick is by using a specific TCPdump container with host networking set to true, although it requires you to have some higher privileges, but in most Kubernetes clusters, it will work. And then the last one, I described it on this link, is by using ephemeral containers, so that you can actually do it in real time without starting pods. It works very well. The problem is that you have to do it on very recent versions of Kubernetes. And your cluster needs to enable or allow ephemeral containers. But if you want to check it out, I described it over there. It's a cool way, but it won't work on all clusters or older clusters for sure. So this is the example. I'll give you the YAML files later on the GitHub page. But basically, if you want to sniff from a pod or a container, in this case, all the traffic that is actually happening on the Linux node, and you don't have access to the Linux node, so you only need kubectl access in this case, so API access. So you can see there is one specific setting which is called hostNetwork equals or set to true. That means that all the host interfaces, so also including all the Kali/VXLAN interfaces, are actually accessible right out of the pod. So that means that inside this pod, you can actually run TCPdump and actually start using and seeing the traffic in the pod. The downside here is that if you want to do this, you actually have to be on the Kubernetes node where the pod that you want to analyze is present. So that's why there is a node selector here that will actually allow you to basically capture the traffic on the specific Linux node. But the cool thing is you don't need any SSH access, or you do not need any node access. So it will work basically on even managed Kubernetes clouds. Okay, so that's it. Cool trick to basically intercept the traffic. The downside is, as I mentioned, you have to be, or you have to actually launch the pod on the host name or the IP address of the node that you want to analyze. For the record, in Calico Enterprise, this is taken care of automatically. Okay, I see there is a question. Let me quickly see if I can. Nope, it's not working for me.
Hey, Philippe, I think most of them are answered, but if anyone has put a question and you don't think it's answered, can you please put it again in the Q&A and we'll answer it live? Excuse me, I have a terrible cold.
No worries. No, I lost my, okay. Okay, so that's one trick to do. It's pretty cool way I'll find myself in trying to get network traffic. Now, once we're more or less sure that our traffic is flowing or that we don't have any big issues regarding network connectivity, we checked the routing, we've seen that we have IP addresses, we could basically go into a pod, see whether we got an IP address and so on and so forth. We can do a basic ping and so on and so forth. So all the tips and tricks we've learned in the past to troubleshoot networking will still work. But what I learned is that quite often we run into issues when we create network policies, whether these are Calico network policies or Kubernetes network policies. It really doesn't matter. It's something that might be very prone to errors. It requires you to really well understand how network policies work and so on and so forth. So I tried to find a way to actually analyze and dig deeper in what and how can I find what. So what I encourage you to do, if you are using, in this case, the open source versions, is, and you can replace Calicoctl by Kubectl if you want, is to first of all see whether there are network policies applied at all. Yeah, so that's very important. Typically, network policies are applied on a namespace, so that's why I mentioned all namespaces. But also know that Calico supports global network policies, which are not namespace bound and wouldn't show up here. So in Calico case, just also remember there are global network policies that might be blocking traffic. If you want to figure out a specific network policy, you can run a command like get network policy for specific deployment. Yeah. And it's always very useful to specify the -o YAML output so that you actually see all the information. I'll show you right away in the demo how I do it to basically find a network policy, find a label, and so on and so forth. Because quite often you might sit in a situation that you say, okay, my pod is not working. How the heck do I figure out if this specific pod has a specific network policy being applied, or is the network policy actually impacting a specific pod? That's actually what is mentioned down here. There are probably other ways to do it. There are probably also a way to do it with filter syntax in Kubectl. But it's always a good thing to see if you have a specific pod, what are actually the network policies that are applied, which is pretty hard to find out because that's not the way it's stored in the Kubernetes etcd database. Okay. Now, if you think this is all cool, and I think it's pretty cool to learn how everything works, there is still the problem of production. What do you do if you quickly want to understand what's going wrong in production and you don't have all the time in the world to do that? Well, of course, that's why we have Calico Enterprise. Calico Enterprise has a lot of cool features. One of it is the flow visualizer. And the flow visualizer will actually show you, this is a very complicated image, but it allows you to drill down on a specific namespace and actually visualize all the flows that are happening from a specific namespace, from a specific pod to external or to another pod. And you will immediately see what traffic is denied, what traffic is allowed, what labels are involved, what policies are involved, and so on and so forth. So it's a pretty cool, I would say, holistic way to see what is going on. If something is dropped, you will also typically see that things start flashing. So Flow Visualizer is a pretty easy way. You also have the metrics and the visibility. So you can also see how much of traffic is being denied and allowed and so on and so forth. Now, the cool thing is here, based on these metrics and quite a lot of other stuff, just picking out a few examples, you can set alerts. So if you would see that traffic is blocked, like for example, 20 times on a per minute basis, you can send alerts. So if something changed inside of network policy or somebody changed some stuff in labels, well, you could have alerts saying you that, okay, we see a normal peak in denied traffic. You could do it with the flow visualizer. You could see it in other places also, but it's always a cool thing to have in place. Last but not least, one of, I would say, most important features is logging inside of Calico Enterprise. So every communication, all communications are happening inside of your Kubernetes cluster is actually logged. Not only IP address and destination, it will show you if the traffic is allowed, how many times that specific connection actually happened, what the source destination IP address were, which labels were actually applied to these pods, as well on the source as the destination. And most importantly, it will also show you which policies were actually involved in allowing or denying this decision. This works as well for Kubernetes policies that were already in place as for Calico policies. Just even if you have already policies in place, if you would install Calico Enterprise, you would already see that data. And everything can be filtered on everything. You can set alerts and so on and so forth. So it's a pretty cool way to have in-depth information, what is happening or being denied if you need to audit or troubleshoot something, the main purpose of logging. So it's for sure quite an interesting data. Based on the data, but it's a little bit out of scope of this topic, based on the data that is collected here, we could also try to analyze this data for scanning or for sweeping attacks or even malicious activity towards external resources like malicious sites or something. So that's something based on this data that also will happen, but we'll discuss this in 2 weeks from now. Okay, now, since at Calico we know that troubleshooting network issues is very difficult to do, for sure also if you want to look at specific payload and so on and so forth, you cannot simply do that with just listing a connection. What we added in the recent version of Calico Enterprise is the ability to do TCP dumps on specific traffic. So what Calico added is a Kubernetes Calico object, as you can see, project Calicoctl for the ABI version of a kind packet capture. And it actually allows you to say, okay, Calico, figure out, for example, in this case, all the pods in that specific namespace and start doing the TCP dump. So by actually launching this through kubectl something, yeah, Calico will do automatic packet captures. They will be rotated, they are stored on the disk, and when you actually want to use that information, you can actually very easily get these packet capture files through the Kubernetes API to your desktop, for example, and analyze them in Wireshark, or if you want via TCPdump CLI. But it doesn't require you to start any type of pods to have privileged access to the node or anything. It's a pretty simple way to actually launch the packet capture. And by simply deleting the resource, you can actually stop the packet capture. We will be using that feature also for further malicious analysis later on the roadmap. So, but the fundamentals are there, and you can fairly easily use it to troubleshoot network connectivity. Before we jump to the demo, I just want to point out that there are still a lot of upcoming events, as well in EMEA, as well as in US timeframe. So here's the list. Next time in Europe, it will be Kubernetes security. So we'll be talking about intrusion detection and mitigation. So As you probably know, otherwise you wouldn't be here, feel free to sign up for these events. If you didn't do yet, it's because we got quite a lot of hits, so thanks for this. You can actually go and get Calico certified. There's coursework behind it, there's a small exam behind it, and at the end of the day, you get your Calico certification. So if you didn't do it yet, and you think, that's a good idea, go to this link, you get the slides after this talk, and you can actually sign up and do this. I already got a lot of people that are doing it, and it's very feasible and very interesting to do. If you want to prepare and if you want to know the ins and outs of Kubernetes networking, our colleagues in the UK and our CTO spend a lot of time writing this ebook. It's a very technical ebook, and it tells you all about the ins and outs of networking services and stuff like this, which we typically discuss in a shorter time frame during webinars. But it's a great, great, great thing to have on your iPad or your computer to actually look up things about Kubernetes network. So I encourage you to download this. And then last but not least, if you think, this looks cool, Calico Enterprise, we changed a little bit the way you can actually try it out. But if you hit tagier.io, you can sign up for a sandbox. You can play, everything is basically done for you. You can play within a sandbox, or you can actually, and I think it's announced this week somewhere, if I'm not mistaken, if you have a Kubernetes cluster, you can actually hook up your Kubernetes cluster to this trial, and you can use your own Kubernetes cluster. If you want to go, of course, full-fledged, feel free to ask Jane or myself, and we can actually do a POC to test it out on your local Kubernetes cluster. For some reason, okay, so let me quickly see if I can see the questions, but for some reason, I'm not seeing any questions. Okay. I did, but no response.
So, hiya, I'm having a conversation with David about Project Calico. So I'm just chatting with the team in the background, so I'm sure we'll get him an answer.
Okay.
I think, all right, cheers.
Cheers, okay, no worries. Okay, so let me close this and let me open this link here. This is just a few of my notes. You can actually access it if you want. Let me enlarge this a little bit. So these are just a few commands I wrote down to make my life easier. So let me organize my screen a little bit. No, this is the wrong way now. Well, this is what I need. Let me enlarge this. Okay, so I really nothing more than a Kubernetes 3-node Kubernetes cluster on which I have like a sample application running and using Calico. Yeah. So if you want to get an idea of what we're running, of course, always do kubectl get nodes. And if you specify -0 you should actually see the versions, who is the master, and of course, important, the IP addresses of our nodes. As you can see, these nodes are sitting inside the same subnet, or in AWS in this scenario. So they can actually reach each other over the subnet. So we could basically have a scenario where we have encapsulation or non-encapsulation, if that's the case. You cannot see it straight from kubectl, but for example, if you would do or execute this command to get the Calico status, You can actually see that you only see 2 here. Don't get mistaken, but this is actually from the point of view from the master. So I'm sitting on the master. We can see that it is peering in node to node. That means that every node in this Kubernetes cluster is exchanging BGP routes to each other, and that these sessions are established. If you would already see that these sessions are not established or not existing, it's time to basically take a look at that part, because it might mean that for some or the other reason, BGP is not working. There might be quite a lot of reasons why it's not working, but maybe it's like a security group that actually, in case of AWS, prevents you from setting up BGP routes. So first things first, if you know you're using Calico with BGP, check this out. Yeah. If node-to-node mesh is not shown, but it shows something like global, it means that your nodes are not peering with each other, but with an upstream router. Then you might also have to check the routers, of course. To get familiar with the IP pool concept, yeah, so you could actually fairly easily figure this out by running Calicoctl get IP pools. And with the -o YAML part, you can actually see immediately the information that we discussed. So as you can see, the pod side is in this case /16, so which is the default, but the block size, sorry, the IP pool size here, sorry, is /16, which is the same as the pod size. In all honesty, I forgot to change it when I was preparing. But that's what you typically would see if you follow a normal install. And the block size actually is the size of the ranges, so /26, that Calico is assigning to every node. So that means that in this case, you can have quite a lot of nodes in your cluster because you can create quite a lot of blocks. You can also see in this example that we're using IP in IP mode, so there is encapsulation, and that we're actually doing not outgoing, meaning is enabled. So these are very simple commands, but just know that these will give you a good insight in how your cluster is operating, for sure, if you're trying to troubleshoot it. Yeah? If you want to see how everything is going from an IP address assignment, well, you can. So again, in what I just said, you can see that the IP pool, which in this case is /16, is split in smaller blocks, like 26. These blocks are actually assigned to nodes. Yeah. And in these nodes, as you can see, we can actually see how many IP addresses we might have in total, how much we might have in total in the entire cluster, yeah, and how much % is actually used or free. So if you can see, for example, on this one, we only have 5% or only 3 IPs in use. So for example, if I would do ifconfig on this node, we're probably only seeing very few Kali interfaces. Yeah. But if I would check the other node here, if I'm still connected now, you would actually see that there are quite a lot of Kali interfaces that are actually running at this moment. So every Kali interface is probably used by a pod or in some cases used by a Kubernetes component. But IPAM show always a good thing to get an idea about how much is running, how much free space I have, because at the end of the day, you might actually deploy something in Kubernetes and it would start saying like pending, and then you have to go through this stripe deployment. it's always a good idea to make sure that you have IP addresses available to actually spin up pods, because you might create scenarios where, of course, it wouldn't work. I cannot show this, but in Calico, as I said, you might have different IP pools. So that would basically mean that you might have different encapsulation techniques and different block sizes and so on and so forth. To make sure a pod is in a specific IP or served by a specific IP pool, you need to annotate the pod or the namespace. So I wrote it down here, but if you have some doubts, check out the namespace. To see whether there are annotations, yes or no. If you see Tagira or Calico annotations for IPv4 pools, that actually indicates that that deployment or that namespace will get its IP addresses from a different IP pool. That's how you select which IP pool will be actually used for IP address assignment. So keep it in mind, and don't forget that. To check out more stuff, you can also actually see, because if you do ifconfig, you can of course not really easily see which interface is assigned to which pods, but luckily we have Calicoctl. So if you actually run Calicoctl, you get all the information you can dream of. Yeah, sorry, that's the wrong window. Yeah, so you can actually see which pod is actually using which IP address on which interface. That's very useful information, because if I would go on that specific node right now and TCPdump, for example, on that Kali interface, or use other tools to actually analyze that Kali interface, you can actually get very useful information. That information is not displayed as detailed with kubectl. With kubectl, you can actually figure out the IP address of the pod, but you don't know what interface it is, so you have to do the math yourself. But with Calicoctl, which is pretty easy to install if you go to Project Calico.
Philippe, we have one question in the Q&A there, which I don't know the answer to. Tell me if you need me to read it out.
Sorry. What are the best practices on cited block allocation for pod service cluster and to avoid IP theft? I don't know what is meant with IP theft, but typically typically what you should keep in mind is the pod sizer is typically /16 or 10/8, which might be big. For sure, if you're using something in a cloud, you might not have that much IP space available. I think it quite often boils down to the fact that how many pods can you actually run on top of a node. And I think as a best practice, we typically say 100 to 110. In a Calico scenario, if you would exceed it, we would add automatically blocks. But I think the /26 for block size is pretty reasonable. It allows you to have quite a lot, I think 64 if I remember well, pods. You can have multiple blocks, so you can go up to 128 or higher. But that's only in Calico. So I would get you to /26 for block or /24 already is quite a lot. Just think about how many clusters you have, how many nodes. The size of the block sizes will also typically define how many BGP routes you have to announce and so on and so forth. So it's not as easy as that, but I think /26 is quite a good figure for the block size. /24 is pretty okay for the IP pool. One thing, and the best practice is, if you configure Calico, for that matter, always make the default IP pool smaller than the pod side, which will allow you to add multiple IP pools and have a lot of flexibility. That's something which is typically forgotten, as I did. But if you install it, yeah, just make sure the Calico IP pool is smaller than the pod side. And you would have a lot of flexibility at that point without wasting a lot of IP address space. But I'm happy to discuss this any further if you want after the session, no worries. We're at the end of the hour. So what I wanted to show you is, for example, the trick on how you can actually TCP dump inside of a container. And let me see. So I'm using the one via the patch command, which I find pretty useful, and it doesn't require you to go and figure out the node. So it's pretty simple. Let me remove that file. Okay, so just create a patch file on a node. Yeah, but I did it on a node, but you can do it from anywhere. Yeah, copy paste this. Of course, you can use your own image containers. These are things I created myself, but there's basically nothing fancy in it. The moment you have a container image where you can actually run TCPdump in it, it should be fine. My internet is so crappy today. Just save it, and then you can actually deploy it to a deployment. So that actually means that we're going to patch the deployment and actually add TCPdump to these containers. So if everything works fine, you should see something like kubectl get pods in, for example, demo. Yeah. You see actually that there are still a few in terminating space, but most of them right now have 2 containers running. Yeah. That's because we actually added TCPdump inside that pod. So if you want to actually see the traffic, in this case, we can actually go in a very simple way. We can actually do an attach to a specific pod. Let's take the first one in this case. All right. Copy paste it. You see, right now I'm actually inside one of these pods, and at this point it's actually executing TCPdump. I'm actually seeing what is happening inside of the pod. Everything was done through kubectl, and so on and so forth. So you don't need basically SSH access. You could actually do it from your MacBook S if you would have access to kubectl. If you want to stop it, great. Right now, the downside is in this scenario that we still have these TCPdump containers up and running, of course. The easy way to undo it is to roll back the deployment. So if I roll back deployment, I just updated, you will see that my pods are actually terminating and that I'm actually recreating new pods with the original content. Cool side of this trick is you can do it with very limited access to the systems. The downside, as I said before, is that your pods are starting and stopping when you do it. So this is the example that you can use to do it on the host network. We're not going to do this today, but at the end of the day, it's pretty easy to do that. Now, if you want to find if there are any network policies applied to a specific environment, well, of course, you can do this. So for example, when I execute get network policies, specific network policy in a specific namespace, you can actually see there is a network policy because I named it. And the one thing to look for is this. That pod selector here actually says to what we should apply the network policy. Yeah? In this case, the network policy is applied to everything with a label or specific label, app equals nginx zone 1, just something I made up. So it's important to do that. If we want to know, and this is very important, which actually pods are implicated here, we can actually look up all the pods with that label. Don't get confused because it's not because it's called app something. Anything can have this label. In this case, it might look like it refers to a specific pod or a name of a deployment, but it can be anything. It could be something like DMZ equals true. Yeah? So once you have the network policy, you know the pod selector, you can fairly easily figure out all the pods that are being protected or might be blocking traffic. So always do it in that way. Yeah. If you want to do it in the other way and you actually want to know which network policies are actually linked to a specific pod, because in this example, I actually went from network policy to the pod. If you want to know which pod is implicated, you can actually use this command. That's why I actually copy pasted it. It's quite long, but it's pretty easy to update. So in this case, I actually asked if a pod like Echo Server 1, which is the network policies that are applied. Of course, I showed you in the slides, we're a little bit out of time, but inside of Calico Enterprise, this information is readily available inside of the user interface. Yeah. I hope it was interesting. Sorry for the internet troubles. If you have any more questions, feel free to put them on mail, Slack. I didn't say it today, but there is a Slack channel for training. So go to Slack and we can try to answer them over there. If you have any suggestions for topics, new things, stuff you want to add or see removed, feel free to let us know. And then we can work on the next versions of webinars so that it keeps on interesting. Thanks, everyone. The post channel in Slack, it's a very good idea. Let me see, I don't know if I can find it that easily. I think it's Academy. I think it's or free training, you can both use them. There's one free training and one Academy. Feel free to sign up there. Okay, everyone. Thank you. Hope to speak to you soon. Hope it was interesting, and let's catch up later. Cheers. Bye.